Hi, welcome to section 1.8. We're dealing with compositions of functions. This is a review from Algebra 2, although we are going to add some domain and range into it, which maybe we didn't do in Algebra 2. So I want to start off today by looking at some basic ideas, and this is going to be the first part of your homework. We're going to ask you for just some basic operations. Let me try that again. Okay, basic operations, which just they mean add, subtract, multiply, and divide. Okay, so as you're looking at it, we're going to add them, and I'm going to show you slightly different notation from Algebra 2 to Pre-Calc. This is an Algebra 2 notation where we ask you F plus G. Your Pre-Calc books writes it like this, F plus G of X. Okay, and sometimes they throw this parentheses in, but I want you to see that there's a difference, and I don't want you to get confused in book notation, so I want to show you there. If we're adding two functions together, if we're adding this f and this g, we want to combine the like terms, and you also want to put them in order. So you should end up getting x squared plus 4x, and then if you'll notice, I can combine a -2 and a -4 to get -6. Okay, and most of this should go over pretty easily. The second one says subtract them. Again, your book will write it like this, f minus g of x, and all that means is subtract them and leave an x in your answer. Okay, so I'm going to actually write this out a second because I'm taking f, which is 4x minus 2, and I'm subtracting g, which is x squared minus 4. Please don't forget to distribute the negative. You end up getting then negative x squared plus 4x, and then a plus 2. Okay, please make sure that you try this on your own and you get that answer. The third one says multiply the two. Again, your book will go like this, f times g of x, and so I want you to see that notation. So if I look at f, which is 4x minus 2, and I multiply it by g, which is x squared minus 4, guess what I'm going to do? FOIL. Okay, you end up getting 4x cubed minus 2x squared minus 16x plus 8. When you FOIL, depending on the way you FOIL, you may get it in a different order. Biggest thing though, order matters. Okay, so FOIL it down here and see what you get. The final one says take f and divide it by g. Your book writes it this way, f over g of x. So I want you to see that. So we're going to take our top fraction, our top function, 4x minus 2, and we're going to divide it by x squared minus 4. The biggest thing though with division, you have to see, one, can you simplify it, and two, what numbers can't you have? The only way to simplify is to pull factors out on top and bottom. If I factor the top, and I'm just going to put it here on the side a second, I get 2 times the quantity x minus 1. If I factor the denominator, I get x minus 2 and an x plus 2. Unfortunately, this doesn't help us because I can't take the factor of x minus 1 and cancel with another factor of x minus 1 because there's not a factor on the bottom. But what it does do for me, well, that means basically this is our final answer. But what it does tell me is what x can't be, because we never want 0 to be in the denominator of a fraction. And so if I have a 2, I'd get a denominator of 0. And if I had a -2, I'd get a denominator of 0. So you have to have this stipulation that says x cannot be 2 or -2. Because if x were 2 and -2, I would have an undefined fraction. And so anytime you're doing division, please also make sure that you put the restrictions in there as well. Okay, and that's kind of what we're looking for here in this domain idea. And I'm going to walk you through actually finding the domain in the next example. But what's going to happen is I'm going to first find the domain of the numerator, second find the domain of the denominator, and then I'm going to find where these two domains intersect. Okay, so I'm looking for the intersection of these two, keeping in mind though that the denominator cannot equal 0. And so if even a part of the intersection makes the denominator 0, I have to exclude that. So I'm going to walk you through one example of that. Get rid of this. Okay, let me write this up again just so that we're ready. So I'm looking one for the intersection of the domains, keeping in mind that the domain or the denominator can't be 0. All right, I made this one a little bit more tricky for a reason. We give you two square roots. Let f be the square root of x minus 4, and let g be the square root of 25 minus x squared. Okay, now we're looking for domains. We're going to find the domain of both f and g. One way to do that is to put it in your calculator. And you can put these two graphs in your calculator and kind of see what the domain and range look like for this. And I'm going to start there. If you look in your calculator, this square root of x minus 4, I'm going to put this over here a second, your graph looks like this. If you look inside, let's go back to section 1.7, inside this mean, go right 4. So I'm going to take a square root function and go right 4, and I'm going to end up getting this graph. And so what you'll notice is from 4 and on, I get values of x. And so this domain in interval notation, which we've already covered, is from 4, including, because I have a value at 4, from 4 to infinity, and infinity we always put parentheses. Okay, so that starts with the first one. You can do the second one in your calculator, and I'm going to put that one down here, and if you go in your grapher and put in the square root of 25 minus x squared, you end up getting this semicircle. Your grapher looks like it doesn't touch, but it ends up touching. If you go to your table, it'll end up touching. This is at a value of -5, this is at a value of +5. So in interval notation, then this is from including negative, oh, I'm sorry, wrong one, including from -5 to +5. Let me get rid of this piece a second. Okay, and again, using your calculator is the easiest way to do this. So the question is, where does this overlap? Well, this goes from 4 to infinity. This goes from -5 only up to 5. And I can show you that right here on a number line. Let's say here's -5, here's 0, here's 5. This one goes from here to here, your G. Your F goes from a +4 and onward. So can you see where the overlap is? If you look, that overlap is right here. Okay, so we would look at our overlap and say our overlap is from 4 to 5. Now, the last step is, does the denominator equal 0? Well, if I take a look, sorry, this is supposed to be a squared. Let's make sure I change that. If I take a look, if I plug in a 4 in my denominator, does it become 0? No. Do I plug in anything else? Oh, look at 5. If I go back to my graph, at 5, I get a value of 0. So 5 cannot be included. So my final answer is from 4 to 5, where you include 4, but you can't include 5, because at 5, you get a value of 0. Okay, and I've walked you through one in the process, and I want to kind of keep you in mind there that you're looking for this process. Find the two domains, then find the intersection, and the intersection is great to look at it in terms of a number line, and then verify, do any of your answers get you 0? If so, do not include them. Okay. The next portion we're looking at is composite functions. This, again, you did in Algebra 2. I'm going to take you in a very different look of composites for just a minute. And I'm going to introduce the smiley face and kind of talk about what that means. If I asked you to evaluate f of the smiley face, what that means is everywhere I see an x, I'm going to put in a smiley face. So, mathematically, here's what it looks like. I take smiley face squared plus 3 times smiley face. And I do this truthfully just to make a point, okay, that you're taking whatever value is there and you're plugging it into your original function. So the second one says f of 5, and we're going to again put the 5 in where each of the x's are. So we're going to say 5 squared plus 3 times 5, and because these are just numbers, we would actually ask you to evaluate them. 25 plus 15 then ends up being 40. Okay, only do that again if you can, but you always want to simplify if possible. You can't simplify the first two though because they're not common terms. The last one, we're doing the same idea. We're taking the g, and everywhere we see an x, we're going to plug in this 2x minus 7. So I have 2x minus 7 squared plus 3 times 2x minus 7. Okay, we again would ask you to simplify this. So if I FOIL this first one, you end up getting 4x squared minus 28x, then plus 49. And then I can distribute the 3 to both, so plus 6x minus 21. You end up getting an answer then of 4x squared minus 22x plus 28. And this would be the answer then we're looking for, and that's considered a composite, where you take one function and you plug it in for every x in the other function. Now, your notation that you're used to in Algebra 2 says f of g of x. Okay, f of g of x. However, your pre-calc book writes it like this: f with an open circle of g of x. And so I want you to know that that open circle means that you're taking a composite. The domain of the composite is the x in the domain of g, which works basically in the domain of f. And we'll talk a little bit about finding domain of composites, but you will more likely see domain of division questions or quotients than you will domain of composites. Okay, so flip the page. We're going to do a couple of composites together, and then we'll show you how to decompose, and then we're done. Okay, we give you two functions. F is 3 minus x squared, g is 2x plus 5. The first thing we're going to say is find f of g. What I suggest is you start with f and leave a space for every x you see. So I'm going to do it this way: 3 minus, and I'm going to put parentheses where I saw my x. Inside of that, I'm going to put g, which is 2x plus 5. Now, we expect that you simplify this. This means FOIL. So 3 minus whatever I get when I FOIL. 4x squared plus 20x plus 25. Okay, now because I'm subtracting that entire quantity, I'm going to distribute the negative, and then what I'm going to do is I'm going to combine whatever like terms I can get. And your answer ends up being negative 4x squared minus 20x, and then I'll end up having a negative 25 plus a 3, which is negative 22. Okay, now are there any values of x in this composite that you couldn't have? Well, no, I could throw in a positive, a negative, or 0 in for each of these x's. So my domain here is from negative infinity to infinity. Okay, and because I don't have any fractions to worry about, it's kind of your big thing where you have to worry about. Fractions are probably the biggest time you'll see a restriction on your domain. The second one, I want to go backwards, start with g. So I'm going to start with g, and where I see my x, I'm going to put parentheses. And inside of that, I'm going to put f, which is 3 minus x squared. All that's left to do is simplify. So I distribute my 2, 6 minus 2x squared plus 5. My answer ends up being negative 2x squared plus 11. Okay, now again, I'm going to ask you, do you have any restrictions on what x could be? The answer is no, because I could put a positive, a negative, or 0 in. Therefore, my domain is all reals, which is from negative infinity to infinity, and we want your domain and range in interval notation. Okay, we're going to go a little easier and ask you to do composites. Basically, when you're putting in a number, when there's a number, I always start on the inside. So I evaluate g of 2 first. So g says 2, and then I put a 2 in, times 2 plus 5. That gets me 9. And then what I end up doing is finding then f of 9, because 9 would be the value I'd plug in. F of 9 is 3 minus 9 squared, or 3 minus 81, which is negative 78. Okay, and again, if there's a number, I would start in the middle. So f of 2 on the next one is 3 minus 2 squared, which is 3 minus 4, or negative 1. And I take that negative 1, then, and I plug it into g. G of negative 1, then, is 2 times negative 1 plus 5. Negative 2 plus 5 then gets you an answer of 3. Okay, and I think you're more comfortable with the number ones because we like those a little bit better in Algebra 2, but I hope composites don't end up being that difficult for you. The last thing we're working on is this idea of decomposing a function. And in order to decompose, basically all they're asking you is what functions were you using originally to plug in. And here's how I remember it. The inside function is normally in parentheses. That's kind of the way to look at it the easiest. So the inside function is always in parentheses. So we always define h as putting, let me try this again. Let's just go erase. We always consider h, again, to be putting g into f. So g is always going to be our inside function. So if g is my inside function, then I look here at this example. Here's what they give me. So I suggested the inside function is always in parentheses. So my inside function, g, would be 3x minus 7. And the inside function always replaces the x in the outside function. So wherever my parentheses were, I'm going to put an x, and whatever's left, in this case to the 4th, is my original function then. Okay, so my inside function is g, my outside function we're always going to consider f. So let's try one more just to clarify. Again, g is always going to be the inside, and it's always in parentheses, so g in this case is x minus 2. And instead of the parentheses in my outside function, it originally was an x, so x replaces the parentheses, and the only thing that's left is to the 4th power. And again, I don't want you to think too much into this. I really hope it's that easy for you. But if you have questions or concerns, please circle it, and we'll discuss them in class tomorrow. Thanks for watching section 1.8, and we'll see you tomorrow with 1.9.